Okay, so this is your video on moles to volume. This is the last ratio. It's called the molar volume ratio. This is 24.1 liters to 1 mole. It's only for gases, and it's only at something we call STP. STP is standard temperature and pressure, and that's an abbreviation we'll go over now and again. What that means is a temperature of 0 Kelvin and a pressure of 1 atmosphere. Again, things you may or may not know, but we will get into those more when we get into gas laws. But just understand that we can use this ratio only if it's a gas and only if that gas is at this temperature and this pressure. So here's an example of a problem. How many moles of N2 gas are there in 56.7 liters of that gas at STP? A couple things. One, gas. Two, STP, so we know that we can use our same conversion. So I write down my given, 56.7 liters of N2. Then I take my ratio, I put liters caddy quarter from it so that they cancel. And then I put 1 mole on top. I then multiply, then divide, and I round my answer to 3 sig fig. So I get 2.53 moles of N2. Working it backwards, how many liters of N2 gas are there in 0.567 moles of that gas at STP? Again, write down my given, take my conversion factor, I put moles on the bottom so they cancel, and then I put 22.4 liters on top. I multiply across, and I round my answer to 3 sig figs, 12.7 liters N2. Again, try these in your calculator. If you don't get the same answers as me, send me a message. Lastly, we have these longer problems like we worked on before. If we have 6.78 times 10 to the 34th molecules of H2 gas at STP, how many liters of that gas do I have? I write down, I start off with my given. Now I have molecules. If I have molecules, remember for counting, we use Avogadro's number conversion. And that's what I have here. Remember, I want molecules to cancel. So I put Avogadro's number at the bottom and 1 mole on top. If I were to stop right here, I'd have moles. But I want to keep going because I want to get liters. So then I take my conversion that we just talked about. Liters will be on top. Moles will be on the bottom because we want moles to cancel. And I get 22.4 liters there. Multiply these two numbers. Then divide by this number, and you should get 2.52 times 10 to the 12th liters of hydrogen gas. That's a lot of gas. And then lastly, what if we have grams, and we want to solve for grams from liters? So it says how many grams of CO2 are there in 56.8 liters of CO2? I did the molar mass of carbon dioxide for you. If you want to check my math, you can, but I think it's right. I have 56.8 liters of CO2. Again, I use my conversion to go from liters to moles. I put 22.4 liters at the bottom, so liters cancel, 1 mole on top. I then multiply by the molar mass. Again, 1 mole at the bottom, 44.01 grams on top. Multiply, then divide, round to 3 sig figs, and I get 112 grams of CO2. So this is very similar to what we've been doing, what we did yesterday. Do the best you can in the assignment. If you have questions, send me messages, and if you're doing this and you need me to do this live with you to show you some things, we can do that tomorrow.